Now we're going to be looking at the proof for a Untitled theorem. So this will be just the proof of what of a Untitled theorem. So the statement in the diagram, the chords Km, Kn, Mn, and Kn, they are drawn in a circle with center O. So this is center O, and then P and Q is a tangent to the circle. Okay, so you already know it's a tangent to the circle at N. So at N we have this tangent. So we have this line being the tangent, and you don't assume that the line is a tangent. Even if you see that the line touches the circle maybe once, unless you are being told that it touches the circle once, then maybe you can assume that it's a tangent. But then you have to be given that it's a tangent, or have another information that will assume that it is a tangent. But then we're just doing the proof here, so let's get on with it. So what I'm going to do here, I'm just going to let this angle be x, and then I'll try and find what the value here, or the value over here, okay, which won't be x. Okay, after I have said this is 90 degrees, then I find the value here, and then I find the sum, and then find the angle over here. Then I'll use what the reason that angle at center will be equal to the angle at the circumference. So this angle at center will be twice the angle at the circumference. So after that I will find the value of k. So the value of k should be equal to this angle that I just started with. So therefore m and q, this angle shall be equal to the value or angle k. So that's what I will be doing. I'm just saying roughly what we will be doing. So now we're just going to put it in words, and then we're going to prove it. So but then it's just a method of proving it. So what we're going to do, we're just going to say we're going to let uh, uh, m and q, m angle nq equals to x. Okay, so this angle will be equal to x. Now after I've said that, I will then say draw on and what, and om. Okay, after I have drawn this on and what, and om, now I'm interested in saying I have a 90 degrees over there, and then finding these angles and say that they are equal. Okay, then I can say maybe first and say that ON is equal to OM. So this will be equal to that, and the reason is just radian. Okay, and then now I will say that ON, okay, I can just say O angle NQ is equal to what, 90 degrees, and the reason that is 90 degrees is that the radius is perpendicular to the tangent, or tangent are perpendicular to what, to radius. Okay, so I have what, a 90 degrees over there. Okay, so since now I have this angle being x, this one being x, and this, the whole and the entire angle is what, is 90 degrees, this angle. So this means that I can find my tiny piece over here, which will be what, which will be equal to this angle. And then after I found it, then now I'll use the sum of angles of a triangle to find this angle, and then I will use what, angle at center towards the angle circumference to finish the proof. Okay, so okay, let's now focus here. We can say that this angle, you know that here we have O, and then this one is N, and this one is M. So we can say that O angle N M will be equal to, we know that it is equal to this angle, is equal to OM, O angle MN which is equals to what, your 90 degrees minus x, because it is the entire angle minus the smaller angle, which we said it is x. Then we find what, this orange angle, so it's 90 degrees minus x. But why are they really equal? It's just because those sides were equal. So you could have been using the isosceles triangle reason, or else you can just use that angles opposite equal sides. Okay, this is the most acceptable reason. Okay, so now that you know that this angle, okay, this angle is what is 90 degrees minus x, and this angle is what is 90 degrees minus x, then you can say that this angle O, therefore this n angle OM will be equal to what, 2x. Reason it's sum of angles of a triangle. Okay, so sum of angles of a triangle should add up to what, to 180 degrees. And maybe if you didn't see that, we can just add all these angles. So you can see that this angle plus this angle should give you what, 180 degrees, because of this triangle, because the angles in a triangle add up to 180 degrees. So we can say 90 degrees plus x, and then plus, okay, we have this, and then we have 90 degrees plus x, okay, and then we add this angle O, n OM, so we have n angle OM, then this will add up to what, 280 degrees. Then I hope you can see that angle OM will just be equal to what, 2x, because this 90 degrees and then this 90 degrees add up to 180, and then they are going to cancel this 180, and then you have so it's just 90 degrees minus x, not 90 degrees plus x. So, and then you have this negative 2x plus these are equals to 0, and then you transpose this negative 2x, then you have positive 2x. Okay, so after you found this, then you can say that your angle K will be equal to x. Reason angle at center is equal to twice the angle at circumference. So you can just say circum. So if this angle is 2x, this should be x, because you have to half the angle at center to get the angle at what, at circumference. Okay, so therefore you can say that your m angle and q will be equal to your angle k equals to x, as proven. It's more like we have proved that we already proved that k was equal to x, and then we said that this m and q was equal to what, to x. So since they are both equal to x, now we have like proven what we were supposed to prove, but theorem. Here we're just going to be looking at the proof for what, for a quadrilateral, for a cyclic quadrilateral. So we're just going to be looking at what, at the proof. So what we want to say is that the opposite angles of a cyclic quadrilateral, they're just going to be adding up to 180 degrees. And to do that, we're just going to be using, what we're going to use, we're going to use what, angle at center equals twice the angle at circumference. So the angle at center will be equal to twice the angle at circumference, so circum. So this is just more like the only reason that you're going to be using in order to prove this. So it's for the easiest proof for this. Okay, fine. What do we just do to start the proof? We just draw you say draw. What you want to draw is more like you want to draw a four-sided, but you don't draw a three-sided. You just draw what a four-sided. But then look at what we want to have. We want to have J and L. So we want to have these being adding up to 280. That means we're not going to draw on them. Okay, so we're just going to draw on others. So we're going to draw this line and that line. So we're going to draw a OK and what an OM. So it's either you say draw or construct, it doesn't matter. So draw OK and OM, and then you say OK is more like equals to OM. Reason is what is just ready, but then this really doesn't matter that much. What we want to say is that, okay, you can just say your OM, your KOM, your K angle OM will be equal to, you can say let angle KOM equals to X. Maybe you can say that this one is X, or just say 2X to be safe. Just say this angle is what is 2X, and then what you're going to be finding is that you can find this angle. So remember, if you are having something like this, you always say that the angle at center is twice the angle here at the circumference. So this is what you are actually saying. So this, if this one is 2x, then J should be what? Should be x. If so, if KOM or K angle OM equals to 2x, then what then angle J will be equal to your x, and the reason is simple. Angle at center equals 2 times or twice the angle at a circumference. So it's circumference, so circum is fine. But then look at this. If KOM, okay, usually they want to say this one is O1. Okay, you can label this to be O1 and this one to be O2. Instead of saying KOM, you can just say this one is what is O1, as long as you labeled it on your diagram. So you can say angle O1, you let angle O1 equal to x. This one is O1 and this one is O2. Okay, and then what you can say, okay, you already say that your J, your angle J is what is x, because angle J is half the angle at center. So your angle O2 should be equal to what, your 360 degrees minus 2x, and the reason is simple. Angles around the point, or angle, okay, you didn't say angles around the point, PT, and then because you see every time we have angles around a point, and then they should add up to what, to 360. So we said that this angle should be what, 360 degrees minus 2x, because this angle is what, is 2x. But then wait a sec, now we are also finding that the angle at center will be what, is twice the angle at what, at the circumference. So we know that angle O2, so angle L will be equal to half, what is half, what, 360 degrees minus 2x equals to your 180 degrees, equals to your 180 degrees minus x. The reason is still the same, angles at center. So angle at center, not angles at center. So angle at center equals to 2 times the angle at circumference. So angle at center equals 2 times angle at circumference. Okay. So after I have done these, and then now I just say angle J plus angle L is equal to what, Your angle J, we said that it is X, then we add what? Your angle J. Your angle J is what? Is 180 degrees minus X, and then negative X, and X is 0, so equals to what? To 180 degrees. So it's already what? Proven. So it's just proven. Okay, so we are done with this proof. Okay, so angles, opposite angles of a cyclic quad, they add up to what? To 180 degrees, or sometimes they just say they are what? They are supplementary. So supplementary and adding up to 180 degrees is just the same thing. Now let's look at a. So now we're just going to be looking at the proof for what? For proportionality. So we are onward on proportionality. Okay, and then we're just going to be looking at what statement. What we usually do is just draw the two heights for proportionality, and then draw the lines over here, and then we're going to be using these height. We're just going to be using the ratios, but then in a form of what? Of triangles. But then you're just going to see that in a while what I mean by that. Okay, so I'm just going to try and do it a little bit slow. I won't just put every information in just one statement and then just do the proof shorter, very short, but then I will try and explain everything that is meant by it. Okay, so what we do, okay, we can just read the statement. So we use the diagram to prove what the theorem which states that a line drawn parallel to one side of a triangle divides the other two sides proportionally. That is prove that xk over ky, so this xk by ky will be equal to your xl by what? By lz. So that is what you're going to be proving. So first I'm just going to draw. Okay, I'm just going to look at for xk as being what? So all of these, they are just being what the base is, like here. So I'm just going to draw a base. Okay, just draw a height, okay, in relation to what? To this base. So I can say that in triangle, what your x k l, draw your height. What I can say, this height is what is h. I can say it's height h. Draw your height h on what? On xk, and draw a line and line. Okay, and draw. I can say just and draw. Okay, let's say this line. Okay, so and draw YL, and draw YL. Why do I do this? Okay, fine. So I have this triangle. Okay, I have this triangle. Okay, I'm just going to use this color. Okay, orange. So I have this triangle. Okay, I want to say that the area of the orange triangle divide by the area of what? Of this purple like what? Triangle. Okay, so if I do that, I will have a ratio, a certain ratio, and then I'll start drawing a certain another height over here, and then with another triangle, and this should give me these ratios after that. Okay, the last ones, but the first one should give me these ratios. Okay, so that's what I'm going to be doing. Okay, check this out. Okay, the area of triangle, what your, this one is x, remember, so of your xkl all over the area of what? Of the purple like what? Triangle. So all over the area of triangle, we can say it's KYL. You can see it's KYL. Okay, KYL. KYL. Okay, so this is equal to, let's look at what my orange triangle. So my orange triangle is half times the base. The base is what is of course xk, and then the height, we said that the height is h. Okay, the height is h. Then all over, now we want the area for this triangle. You can see that the purple triangle also has a height of what, of h. Okay, so it has this base which is what, which is ky, and then it has the height. Remember that, okay, I also made like the video for what, for area of triangles, that if you have a triangle of this sort, you can just draw a, a height, and then say, let's say this one is a b c. Okay, then c bc will be what, will be the base. And then if you have also a triangle looking like this, okay, so say it's a b c, then you can just draw what, a height, more like which is going to be perpendicular to the base, and then it's also half times base times height. Then your half times your base now is bc, so your base is what, is bc, then times your height, this is your height, okay, times your height. I don't know what your height is, okay, just this distance. Your height is not ac, it is what it is, this height. Say this one was f, so it was going to be af, okay, so your height would be what, af. Okay, so okay, I'm just going to remove this. All right, because the height just shows like more like the length between like the base and the height, the perpendicular length between the base and the height. Okay, not a slant height. Okay, fine. So now what you're going to do, we're just going to say it's half then times the base. The base is what, is of course ky. Okay, for this triangle, the base we said is ky, so it's ky, then times what, the height, which is h. As you can see, that things just cancel out over here, so this one cancel with this and this one cancel with that. So what we are left with, we are left with what, with xk all over what, over your ky. So that's what we want, by the way. So now I'm just going to remove this. Okay, now that you saw that I used these triangles, so now I'm going to make the last okay, statement, big statement like that. So we're going to say now, okay, in triangle, same this triangle, the orange triangle, okay, so in this triangle, the orange triangle, okay, in triangle xk l, we're going to draw a height. We're going to say maybe now the height is now k, okay, on what, on xl. Okay, so on xl we're going to draw something. Okay, let me use this color. So we throw what, a perpendicular height, or maybe you can say of course, by the way, the height is going to be perpendicular, so it's height what, k, on what, on xl. So this is xl, you have what, your height of k. Okay, and say we draw a what, this line, your kz, which is k z. Okay, so now we're going to be looking instead these triangles. Okay, maybe I should remove the last information for the last part. Okay, so maybe I should remove it. Okay, I was trying to fit it in, but then in most cases you're going to find it fitted in. Okay, so more like everything in one place. Okay, but I'm just trying to make you understand this. Okay, it's not complex at all. So we have k, and then so we have draw, we drew what, your kz, this line. And then I'm still going to say this is my orange triangle, which by the way I'm going to be comparing with my purple triangle. Okay, remember that the purple triangle has now what this height of what of k, and then this x this one is x k l also has a height of what of k. Okay, because you could have drawn it either side. You could even draw it down and then a perpendicular height here. Okay, so but then we chose now to have a base of what of xl. Okay, so area, okay, let me write in what in orange. So area of triangle what x kl all over the area of triangle what this triangle, this small triangle in this way, lz what my lzk, right? So it's my lzk. Okay, so it will be equal to for the area of x kl is going to be half, then multiplied by you can see that the base now is xl, so it's multiplied by xl. Okay, I can say multiplied by xl like in dot. Okay, then my height is what is k, then divide by, you can see that it's also half this one lzk, half times the base, we said it's lz, so it's lz, then multiply by what the height is k. So we have now your xl all over your lz. Okay, and you don't cancel out these l's because these are just sides. These are not letters that you can just cancel. These are sides, different sides. Okay, so what you're going to see, what we see is that the orange triangle, it was the same as this orange triangle. Okay, so it was just the same, we were just using the same triangle. So we already see that this is equal to that. Okay, so if we were to find something and say like these denominators, if the denominators were equal, then we will see that we could just equate these ratios because essentially they will be just equal. Already the numerators are equal because it's just the same triangle. So now we want to find something about the denominators. Okay, so the area for denominators. But remember something, okay? We had this area, okay? We had this triangle, okay, and the blue triangle. More like the blue or purple. Okay, now the color is kind of confusing. Okay, so what we know is that the triangles in parallel lines, they're going to be equal. So the area of triangles, not that the triangles are going to be equal, but then the area for the triangles in parallel lines are equal. So essentially the area of this triangle will be equal to the area of that triangle. Just in case you are curious, like why would that be? So I think, but then anyways, you once proved the midpoint theorem. There's no point in doing this, but then I'll just do it. Okay, so we have this triangle. Okay, I say we have this triangle. Okay, we say that these lines are parallel. Okay, so if I have this triangle and say my base, okay, so it was continuing and then continuing, something like that. Okay, and say this one is a b c and d. Okay, if I had this triangle abd and then I drew my height, okay, through my height here, and then say it's perpendicular like here, then the area for triangle, so area of a triangle abd you can see that it will have the same base. Okay, it will have a base of what, of um of AD, so it will be half times the base of, okay, maybe I should write it over here. Okay, I hope it will make sense. Okay, I hope it will make sense. Okay, so it will be half then multiplied by the base. By the way, like here you should have already seen that we could just say, now after that we could just say your xk will be equal to what, your ky, over ky will be equal to your xl over what, over your lz. The reason being is that these board areas, the board areas, okay, the numerators, they're just the same triangles, and the area of the bases of the denominators, these denominators, they have what, because they lie between two parallel lines. It's the area that lie between two parallel lines, so they have the same base and the same height, therefore they are equal. So I have the same base and what, and same height, so then they are equal, because the area of a triangle is half times base times height. If the base and the height, they are both equal, therefore these areas will be equal, then therefore this will be true. Okay, now I'm trying to show you like why we're going to be saying that. Okay, now let's draw another triangle. Okay, we saw that here we have half times, then the base is what, okay, we said it's AD. Okay, try to keep up. We can see that this one is the height, so this one is what, is the base, of course. Okay, so now I'm going to draw this triangle. Okay, so I'm going to draw this triangle. Okay, now it's look okay. So I'm going to draw a triangle like over here, and then after I drew this triangle, now I'm going to draw a height. Okay, so okay, this is my height, so that is my height. Okay, so obviously you should see that in this triangle you can see that here we also have a base of what, of AD. So for this triangle, the area of this triangle should be equal to what, you have 10 times your base. Your base is also AD. Okay, the height here, we could just say it's the height. We don't know what this height is. Okay, then but the base for this triangle is also like AD, and then the height, since this forms like a rectangle, you see that the opposite sides are equal, so times height. So that's it for this proof. Okay, now continuing with the proofs. So here now we're just going to be proving, okay, it's just a proof. We're just going to be proving that a line, okay, that an angle at center, so an angle at center is twice, two times the angle at circumference. So it's just a proof that's going to be proving like over here. So what you do with this proof, you're going to see we're just going to draw a line. After we drew a line, we're just going to make one angle equals to x and the other equals to y, and then you can see that these are equal, so this will be y, so this one will be 2y. As exterior angle of a triangle, this one is 2x, so this one will be x. As you can see, this will be 2 into what, your x plus y, which is twice what this one. If this one is x, because of this equal, since you can see that we have what, an isosceles triangle, then you can see that angle A, we have x plus y, and then you can see that at the center we're going to have like 2 times x plus y. So it's basically what you're just going to be proving. We're just going to be doing it like that, but now I'm just going to state it a little bit more nice, a little bit more presentable and stuff. Okay, but I'm just showing you like the feel of what is going on, and there's nothing else that you do in the proof. You just do what more like I did, and then you're just going to write it a little bit more formal. Okay, so what you're going to do, as I said, we're just going to construct a line. So you can say draw, or rather say construct. Read doesn't matter. Construct, but draw seems nice. A line that passes through, a line that it passes through. Okay, a line OA, maybe say maybe a line or OA. Draw a line or an extended line from A to O. Okay, from A through O. Okay, so construct a line from A through O. Okay, it sounds more right in that sense. So because I just want to construct a line like over here. Okay, so and then after you did construct it, and then you're going to say, maybe you're just going to say let angle B equals to x. Okay, so we have angle B equals to x. Then we can say maybe this one. Okay, and then if angle B is equal to x, then it will be equal to this angle. So it will be equal to what your BAO. So your B angle AO, and the reason is just since these are equal. So maybe you can just make a statement first before this one and say that your BO will be equal to what your OA. Reason already. Then after you have already said that these are equal, then you can just say these angles are equal and say your reason is angles opposite equal sides. Okay, so that's your reason. And some people just like to say it is an isosceles triangle. I don't see much um, objections towards that reason, but then the most acceptable reason is these kind of reasons. Okay, fine. So now we're going to let angle C equals to y. So we let this angle equals to y. Okay, but we remember that these sides are equal, so we remember that your OC is equal to what your OA, and the reason is just for D. So if they are equal, that means this angle is also equal to y. Okay, that means that this angle is equal to y. So it means that you see angle A O is equal to y. So same reason, angles opposite equal sides. Okay, so and then I see something. You remember that when we said we have a triangle, and then we say that if this one is x and this one is y, then this angle is x plus y. So the exterior angle of a triangle is equal to the sum of the interior opposite angles. Okay, so we already said that this one is y, so this angle was x and this one was y. So angle A is equal to x plus y. It's very clear, very clear. Okay, so and then what we say is that we remember this, that the exterior angle of a triangle is equal to the interior opposite angles. Now look at something. So we may say that this one is O1 and this one is O2. Therefore you can see that your angle O1 is equal to what? It is equal to the exterior. Okay, let me, so the exterior of an angle like here, okay, the exterior of a triangle will be the interior opposite angles, the sum of the interior opposite angles. So O1 would be 2x, just like O2 will be 2y. So angle O2 is equal to what? 2y, because it is this sum of these two angles, the interior opposite angles. So this one is 2y and this one is 2x. So therefore your angle O, this BOC, so BOC is what? Is equal to what? Your 2x plus 2y. So it's 2x plus 2y. Take a common factor 2 into what? Your x plus y. So is equal to 2 into what? Into x plus y, which is, and x plus y is what? Is equal to your angle A. So it is twice angle A. So that's it for this proof. Okay. So what we want to achieve in similarity, you want to join like 2 points and make sure that okay, you're going to draw a point and maybe call it, let's say H, and this one call it P, and then when you are throwing it, you want to say that these they are what? They are equal, and this one is more like equal to this one, and then you're going to find that this triangle will be similar to this triangle. Once you found that, what you want to find at the you want to find that this line is going to be parallel to this line. Once you found that, it's when you're going to be able to say that, to claim that your maybe your over because you're going to see what you are having. You want it to be over the denominator, the side that you have. So over your AB should be equal to what? Your your AP all over your what? Your AC. So it is this side, the smaller side over the longer side, and then the smaller side over the longer side. So that's what you want to achieve. And then you're going to say, remember that your AH was equals to DE. So then you have like your DE over your AB equals to, and then your AP is equals to your DF. So your DF over your AC. Okay, so this is what you just want to achieve. I'm just going to remove this, which is what we don't need, and then I'm just going to state it as you know, a little bit more formally, a little bit more formally. So okay, maybe let me remove it in one go. Okay, so this is off, this is off. Okay, fine. Now let's start. Okay, so we want to say, okay, we can say through H on what? Okay, on AB and what? And okay, maybe draw H on AB and say P on what? Let's say DF on what? On AC. Okay, so you want to draw it on what? On AC. So on AC, like you want to draw it over here. So you can say that such that your A, okay, this one is H, this one is P, such that your AH will be equal to your DE by constructing this, and what, and your AP is going to be equal to what? To your DF. Why do you want that? You want these to be what? To be similar. Okay, so that's what you want to achieve. Okay, as you can see, this one will be equal to this to this one, and then this length AP will be equal to what? To your DF. By what? By construction. So now what you have to do is just show that they are what? They are similar, these triangles. Okay, so you can say that your angle A is equal to your angle D. This is by construction. you can see that. Okay, no, it's given, I mean, so you can see that it's given, and then you can say that your AH equals to DE, and what, and your AP equals DF. Both of these are by what type? By construction. So by construction. Okay, and then therefore what you can say, so these sides, okay, they more like equal, and this one, and then we have an angle in between. So it means that triangle, you can say just triangle a. Oh, so when you draw your H and what and P on AC, then you're going to draw what? You can draw what? You can say draw, and we can say and draw what, HP. Okay, so that it is constructed. Okay, once you say a triangle, we know that you already draw what, through what, a line. Okay, HP. So you can say that your triangle AHP is similar to triangle what, DEF, and the reason is that we saw that we had these two sides that are in between and one angle which is included, so we have a side angle side. Okay, so if these are similar, that means that these angles, they are sort of what, of similar, so they are similar. That means that therefore your angle AHP, your angle, your AH angle, your A angle HP will be equal to what, your E, since these are similar, and then, and what, and your APH, A angle PH, will be equal to your F. Is more like by similarity. Okay, that you just proved. Okay, if this is equal to that angle, and this angle, okay, is equal to this angle F, that means what we are essentially having is that, remember that angle A is equal to angle B. That means these angles are equal. Therefore, you can say that, okay, maybe let me use black. So you can say that your A H angle HP is equal to what, your angle B. Why? Because you found out that these were equal. So you found out that you know that B is equal to angle E, because B, you can say B is equal to what, angle E. So and you know that AHP already said that it was equal to angle E, and the APH was equal to angle F. Okay, so and then you can say that what, okay, you already know that these are equal. So once they are equal, and then you know that these are equal as well, you don't have to state it anyways, but then we can just state it. So your A angle PH is equal to what, your angle C, since, okay, you can even write since what, since angle F is equal to what, your angle E. Okay, is equal to your angle C. All right. Okay, and then once you said that, then what you wanted to achieve, remember, is parallel lines. Once you found parallel lines, then you can do what, you can do proportionality, okay, in order to find this. Okay, so you're going to say that your HP is going to be parallel to what, is parallel to BC, and the reason is that the corresponding angles are equal. Okay, so the corresponding angles are equal. As you can see that this angle is equal to this angle, and then that angle is equal to that angle. Okay, so corresponding angles are equal. Okay, So once we did that, what you're going to say is that your AH all over the longest side, which is AP, because what you can see here, you want to include it. Okay, so and then you have like your DF, not your DF here, but then okay, what am I doing? I'm saying your AH all over the longest side, which is AP, is going to be equal to your AP all over your AC. So it's equal to your AP over your AC. You want to include AC, okay? But what you know is that your AH, from here, you know that your AH equals to DE. So you already have your DE over what over your AP. What else do you know? You know that your AP, there is your AP is equal to what? DF. Therefore, you have your DF all over to your AC. And then you can just state it that you can just say your AH equals to what? Your DE, and what? And your DF equals your AP. So your AP equals what? Your DF. So that's pretty much it for the proof of this of similarity. Okay, since I was just being asked to find this one, I don't have to find other ones. Okay, so that's pretty much it.